This video will be doing an exponents review. Let's begin. So, we want to write each number using exponents. So, remember what an exponent is it's repeated multiplication. Just like 6 plus 6 plus 6 plus 6 would be like, a faster way of writing that would be like 6 times 4. Exponents is like that, except it's very similar to that, except it would be like, what's 6 times 6 times 6 times 6? That can be written as 6 to the 4th. So let's go down to 6 times 6. You are multiplying 6 twice, it is 6 square, or 6 to the second power. Number 2, negative 5 times negative 5 times negative 5 times negative 5. When you are multiplying a negative like that, what's going to be really important is that you write it like this. Negative 5 square with parentheses. Now, why the parentheses? It's because it indicates that the negative 5 is being multiplied, not squared, to the 4th power, not squared. Let me erase that. It's negative 5 to the 4th power because there are 4 of them. It indicates that negative 5 is being multiplied 4 times. We're going to give you an example later of something that is very similar to this, but completely different. So you do need to put the parentheses around when you have repeated multiplication of negative numbers. 27. 27, you might be thinking, well, that's just 27 to the 1st power. Yes, that's true. But you can also say that it is actually 3 to the 3rd power, because 3 times 3 is 9. And if you multiply 9 times 3, that's 27. So 3 times 3 times 3 is 27. 4 times 4 times 4 times 4, that one's simple. It is 4 to the 4th power. Number 5, we have a times a times a. That's 3 a's being multiplied together. A to the 3rd power. Finally, number 6, 1 half, 1 half, 1 half, 3, 4, 5, 6. 1 half to the 6th power. Now, this one, again, you're going to want to put it in parentheses because otherwise it looks too much like 1 to the 6th. So 1 to the 6th divided by 2, or it might also be mistaken for like 16 divided by 2. So when you have fractions with exponents, you will have to put those in parentheses as well. So remember, with negative numbers and with fractions, you need to have a parentheses around them. Number 7, let's go to this next section. We have a couple terms, base and exponent. The base, right here, 12 is the base. The exponent is 2, so base is 12. Exponent is 2. Expanded form means like, hey, write this out. 12 times 12. Or I should have used the dot. It's all the same. Standard form is to simplify it to its simplest form, which is multiplying 12 times 12, which is 144. Number 8, the base is the 1 half. So base is 1 half. If you put parentheses around it, that's fine. You don't necessarily have to. The exponent is right there. It's the 3. It's to the 3rd power. Expanded is 1 half times 1 half times 1 half. I'm using the dot this time, not the x. And standard form, well, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So standard form is 1/8. All right, this one, number 9. Number 9 is a strange one. The base is technically just the 9 right there. It's just the 9. The exponent is 3. Expanded form is 9 times 9 times 9. Now, you see this negative on the outside, you may be thinking, like, where does that apply? Well, technically, because the negative is in front of it, if you remember PEMDAS or GEMDAS, remember PEMDAS, where you do parentheses, exponents next, and then multiplication, division, addition, subtraction. Technically, this is like a negative. Right here, this is a negative being applied or multiplied to the 9 afterward. And we do the exponents before we do that negative symbol multiplication thing. if you want to think of it that way. So you have to do the exponent first. So it's actually 9 times 9, and then you would do the negative afterwards. So expanded form, better way to kind of think of it is like negative 9 times 9 times 9. So you do all of this first, and then you'll apply to the negative afterward. So the standard form, 9 times 9 times 9, shoot, I don't know what that is off the top of my head. That's 9 times 9 is 81, but 81 times 9 is 9 and 72, I guess. 72, 729. I think it's 729. Hopefully I'm not wrong, but I could be. Negative 729 is going to be the standard. So yeah, this whole number right here, this is kind of an odd one. Just like number 2 was kind of an odd one. Remember, if you have the negatives, you want to put it in parentheses. This one means something different. It's just 9 to the third, which you're going to make negative. Now, what's the difference between that and that? Well, it's because if you multiply negative 5 times negative 5, you get positive 25. If you multiply by negative 25, negative 5 again, you're going to get a negative answer, so negative 125. But if you multiply that by negative 5, because again, a negative times a negative is a positive, you're going to end up with a positive answer. So it is very important. Whereas when you've got like something that looks like this, without parentheses, when you simplify it in standard form, it will always have a negative answer. All right, so it's always going to be negative in standard form. Where's the other one? Will change. So let's take a look. Write in expanded form. Oh, that's easy. 8 times 8 times 8 times 8. It looks like they don't want us to actually simplify it. Thank goodness. 3 squared. Well, that's just 3 times 3. 8 squared. Squared just means you're multiplying it twice. Remember, like squared, like a base and a thing. If a square, if it had a side of 8 and a base of 8, when you square it, you're multiplying it by itself. That's why they call the second power squared. Nifty, huh? Negative 7. That would be negative 7 times negative 7 times negative 7 times negative 7 times negative 7. And by the way, is that if you put it in standard form, you know, if you multiply it out, would it be a positive or a negative? Well, let's think about it. 2 negatives equal positive times a negative, which makes it negative, which makes it positive, which makes it negative again. So you should have a negative answer as standard form. 7 cubed. For those of you who don't know what cube is to the third power. So 7 times 7 times 7. 15 is 3/4 to the 5th. That's 3/4 times 3/4 times 3/4 times 3/4 times 3/4. I think I wrote that 5 times, right? 1, 2, 3, 4, 5. Yep, that's it. All right, write in standard form. Standard form means you want to multiply it out and simplify it. So 8 to the first power is 8 times just nothing. It's just 8. Nifty. 17, 2 to the 4th power. Well, 2 times 2 is 4. 4 times 2 again. Well, let me actually write it on the side. 2 times 2 is 4 times 2 again, which is 8 times 2 again, which is 16. All right, it is 16. 4 squared. That's just 4 times 4. It's not 4 times 2, but 4 to the second power, which is 4 times 4, which is 16. Negative 2 to the 4th power. Negative 2 to the 4th power. Let's think. Here's a simple rule. If you have an even number of negatives, the answer is going to be positive. And if you have an odd number of negatives, you're going to have a negative answer. So we do know we're going to have some kind of positive answer. I'm going to go ahead and indicate that by writing a little plus symbol. But 2 times 2 times 2 times 2, well, it's the same as 2 times 4th above. So it's positive 16 or just 16. You don't have to write the positive. I just, helps you determine in the beginning. 5 cubed. 5 cubed is just 5 times 5 times 5. So 5 times 5 is 25 times 5 again is 125. Negative 3 to the 3rd power. Let's think. Let's add the exponent. There are 3 negatives, so negative times a negative times a negative. You're going to end up with negative. Remember, because odd numbers of negatives being multiplied together means you're going to have a negative answer. So 3 times 3 is 9, and 9 times 3 is 27. So negative 27 is your answer. Let's look at number 22. 3/5 to the 2nd power, or 3/5 squared. That's 3/5 times 3/5, which is 3/5 times 3/5, which is 3 times 3 is 9. 5 times 5 is 25. Can I simplify that further? Nope. I think that's the right answer. I think that's the best answer. 3 to the third, 3 cubed. 3 times 3. Well, we already figured it out above. It's 27. All right, next one. Write each expression in standard form, then compare using less than, greater than, or equal to. Write each expression in standard form, which is like these. So standard form, then compare using greater than, less than, equal to. All right, let's do that. 3 squares, 3 times 3, which is 9. 2 to the third is 2 times 2, which is 4 times 2 again, which is 8. 9 is greater than 8. Let's look at 25. 7 to the third. 7 times 7 is 49 times 7. Ooh, I'm going to have to do that on the side. That's okay. 9, 4, 5, 6, 63. 7, 14, 21, 28. 28 plus 6, 30, 31, 32, 33, 34. I think it's 34, 343, I think. 21, 28, 28 plus 6, 34. Yeah, I think that's 343. So that's, erase this. That's 343. And 7 times 7 times, oh my gosh, I didn't even have to do this because 7 to the third is 7 times 7 times 7. What a waste of time. Those two are equal. All right, for number 26, I'm actually going to look at what I have. 5 to the third times 5 times 3. 5 times 5 already is 25, which is bigger than this, which is 15. So this is 125. This is greater. Number 27, negative 3 times negative 3. It is a positive answer because it's 2 of them, and it's going to be 9. 2 to the fourth is, I think I figured it out all right. It's 16. 2 times 2, 4. Times 2, 8. Times 2, 16. 16 greater than that. 2 squared is 4. 2 cubed is definitely bigger. But just in case you didn't know, it's 8. 4 to the third and 4 cubed. 4 cubed is 4 to the third. I don't care about figuring that out this time. They are equal. Let's go down. It says circle the correct answer. 48 in exponential notation. Exponential notation means with exponents. 48. So is it this? It is not. That is... Actually, 48 in exponential notation. Let's see, 8, 16, no, because 8 times 8, 8 times 6 is 48. 8 times 8 is already 64, so that's not it. 6 to the 8th power, well, 6 times 6 is already 36. If I multiply by 36 times 6, definitely bigger than 48. 48 to the 0 power, just in case you didn't know, anything to the 0 power equals 1. So if I add like x, some mysterious number to the 0 power, that equals 1, all right? So any number you put in there, whether it's 100 to the 0 power or, 2 to the 0 power, that's going to equal 1. So that does not work. 48 to the first power, yeah, that equals 48. Base is 4, exponent is 5. Remember, the base is a larger number. The base right here is 45. Base is 4, but you're multiplying, so that's multiplying by 5 is not an exponent. Base is 4. Exponent is 5. That is correct. And this is the opposite of that. 216 in exponential notation. 216. Let's see. 6 times 6 is 36. And 36 times 6, does that equal 216? Well, 6 times 6 is 36 again. 6, 12, 18, 19, 20, 21. 216, I think that's our answer. 3 to the 6, I don't think that's it. 216 to the 0 power, again, that's 1. 21 to the 6 power. No, 21 times 21 is already way too big, but let's just check. 3 times 3 is 9. 9 times 3 is 27. So that's 3 times, so that's 27. 9, 27 times 3 again. 27 times 3, that's 75. And 75 plus 6. So 81, I believe, times 3 again. 81 times 3. Let's try that. That's 3, and that's 8, 16, 24, 243. Yeah, and if you multiply 2, yeah, that's way too much. So that's only 1, 2, 3, 4, 5 threes. Nope. Not correct. All right, finally, write what is 2 to the third plus 3 to the fourth. 2 to the third is 8. 3 to the fourth is, I have no idea. I just figured it out. 3 times 3 is 9. Times 3 again, which is 27. Times 3 again, which is 81, I believe. Yep. So 8 plus 81. Well, that equals 89, I believe. Holy cow, I don't think there are multiple answers, but this definitely wouldn't be it. This definitely not it, because 5 times 5 times 5 is our 125, and 18 is also not the answer. So 89. All right. And that's it for our review. Hopefully you remembered all that. Watch it again if you need to.